Hello everyone, in this video we are going to look at Science Paper 1 2022 GCE. Specifically this one is coming from length and time, okay, specifically time. So the diagram which is shown here, it is called the simple pendulum. So the simple pendulum can be used to measure the time interval, okay. So in this presentation we are just going to answer question B1, okay. So, if you are new to this channel, kindly subscribe for more videos. So the question is saying, figure B1.1 shows a simple pendulum suspended on a clip stand for determining the periodic time. Okay, so we have point A, B, and C. Okay, so before I answer the question here, let me try to explain a little bit here. Okay, so under the simple pendulum, they can ask you to give them the factors that does not affect the period of the pendulum, or the factors that can affect the period of the pendulum. So the factors that does not affect the period of the pendulum, the first one being is the amplitude, which is this angle here. Okay, so the amplitude does not affect the period of the pendulum. Okay, so the amplitude is just the angle. The amplitude, it is the angle. Even if you increase the amplitude, even if you increase the amplitude, the number of oscillation will be the same. Apart from that one, even if you increase the mass, or reduce the mass, the number of oscillation will be the same, or the periodic time will be the same. Okay, so we have the amplitude and the mass of the bulb. These two does not affect the period of the pendulum. Now, the factors that affect the period of the pendulum, the first one being is the length of the string. The length of the string. So, you are going to find that when you increase the length of the string, there will be reduction in the number of oscillation. Now, let me repeat. I'm saying when you increase the length of the string, there will be reduction in the number of oscillation, or the periodic, the periodic time. Okay. So apart from that one, when you reduce the length of the string, you're going to find that there will be more periodic time which is going to be produced, or the number of oscillations which is going to be produced here. Apart from that one, let me also try to give you some ideas on this part here. So at part B or point B, the bulb was in equilibrium. When you say equilibrium, which means the bulb was at rest. Then as for C, at C, the bulb was having maximum potential energy, and then at B, the bulb was having maximum kinetic energy. Then at A, the bulb was having a maximum potential energy and zero kinetic energy. And similar to C, yeah. So the first one here it is saying, which is question A, what is meant by periodic time of a simple pendulum? 1 mark. So now, you are going to agree with me if I say period of the pendulum is equal to time taken over number of oscillation, because this one is a formula. So by defining, I'm going to use the formula which is going to help me to define what periodic time of the simple pendulum is. So I'm going to say periodic time of a simple pendulum, it is the time taken. So I will just start with time taken for one complete oscillation. So the time taken for one complete oscillation, the time which is going to take for the bulb to complete one oscillation, that one is called the periodic time of the simple pendulum. So the time taken for one complete oscillation, it is called the periodic time. Then as for B is saying state two factors that do not affect the period of a pendulum. State two factors that do not affect the period of a pendulum. So the first one being here, it is the amplitude. The amplitude is the angle. Apart from the amplitude, we can say the mass of a bulb. The mass of a bulb. Okay. Then as for C is saying this experiment is done on Earth and repeated on the moon. Okay. So this experiment was carried on the Earth, and also this one was carried on the moon. Now what you need to understand here, they want you to apply now under the gravity. What is going to happen if we do the experiment on the moon? What is going to happen if we do the experiment on Earth? Now, when you talk of the moon here, the moon has a low gravitational field, which is 1.6 Newton per kgs. Then the gravitational field of the Earth, it is 10 Newtons per kgs. So you are going to find that on the moon there is no air. As the result, if we move, if we move the ball from point B up to A and let it go, we are going to find that if we are doing the experiment on the moon, we are going to find that the bulb is going to move with the constant speed, with the same speed, okay? Because there is no air, okay? As the result, there will be more oscillation which is going to be made, or the periodic time which is going to be produced. But on Earth, if we do an experiment on Earth, we are going to find that since on Earth there is air resistance, so the air resistance is going to oppose now the motion of the bulb. As a result, the number of oscillations which is going to be produced will be less. Okay, so the question is saying, where would the periodic time be higher? So here I'm going to say the moon, because there is no air. As a result, no air resistance will act on the bulb. So justify your answer in Roman numeral number 1, which is Roman numeral number 2. So here I'm going to say because there is no air resistance. So that was the last one. See you next time. Thanks for watching.